Chapter 2, Lesson 7, Perpendicular Lines and Right Angles. So our perpendicular lines theorem says that if we have two intersecting lines that are perpendicular, then they form four right angles. So by definition, perpendicular lines only intersect to form one angle. So the difference is the perpendicular lines theorem says that if you have one angle, then you will have four angles. So we're going to finish the following proof to show all four angles are right angles. So I'm starting with my statements as two lines are intersecting and perpendicular. Okay, that is given. And so I'm just going to do two lines, and it's saying that it's perpendicular. So here I have angle 1 is perpendicular, and that is because that's the definition of perpendicular. It says that if you have two things that are perpendicular, it makes a right angle. Then the next thing we have is then, since we know angle 1 is a right angle, then its measure is 90. So that's the definition of right angle. Now I'm going to go ahead and label all these other angles up here. So we know that this is angle 2. We're going to call this one angle 3 and call this angle 4. Again, we're trying to prove that they are all right angles. So the next one says, how do you know that the measure of angle 1, which is right here, equals the measure of angle 3, which is kitty corner from it. So they're across this way. And we know those are called vertical angles. Now, if we say measure of angle 1 is 90 and measure of angle 1 is equal to measure of angle 3, then we can say measure of angle 3 equals 90. So what we did was we said they were both equal to the same thing. So now they're equal to each other. That is the transitive property. Okay, the next thing we can say is looking at the picture, we can say that angle 1 plus angle 2 equals 180. Well, that's true because those are supplementary angles. So now instead of saying measure of angle 1 plus angle 2 equals 180, we took out the angle 1. Up here we said it was equal to 90, so we put that down here in its spot. So that is substitution. Now they got rid of the 90. They moved it over here by subtraction. So now we have proven that angle 1 is 90. We've proven that angle 3 is 90, and we've proven angle 2 is 90. The last one they're saying is that 2 and 4 are equal. Well, that's true because they are verticals. And back to this where if angle 2 is equal to 90 and it's also equal to angle 4, then those two must be equal to each other. That is transitive. Use a diagram to answer exercises 1 through 11. If I feel like part of my words got cut off, it should say in the diagram, that's what's missing here. In the diagram, LQ is perpendicular to RM. So LQ is right here in RM, and they are perpendicular. So that's why they put this 90-degree symbol right here. And RM is perpendicular to RP, so that's where this 90-degree angle comes from. And then what's missing is it says measure of angle LRM is 25. So that is angle 1 there. Find the measure of each of the following. So if we know angle 1 is 25, now it wants MRP. Well, MRP right here is 90 because it makes that right angle because it's perpendicular. NRQ right here, also 90. NRL, which is this back one, also 90. Angle 2 plus angle 3, see that little square? Also 90. Angle 3 plus angle 4, See that little square? Also 90. Angle 1 plus angle 3. No, angle 1 plus angle 2. Also 90. Right here. Okay, so if I know that angle 1 plus angle 2 is 90, and I know that angle 1 is 25, subtract 25 to both sides, and I get 65 for angle 2. Now, according to number 4, it says angle 2 plus angle 3 equals 90. So I know 65 plus angle 3 equals 90. So angle 3 must be 25. And I know angle 3 plus angle 4 is 90. I know that angle 3 is 25. So that means angle 4 is 65. So now knowing that, I know that angle 1 and angle 3 are always going to be the same. And then angle 2 and 4 are going to be the same, and they are the complement to 1 and 3. So if measure of angle 3 equals x, the measure of angle 1 would also be x. And the measure of angle 2 and angle 4 is going to be 90 minus x. If measure of angle 4 is y, measure of angle 2 would be y. And angle 3 and angle 1 are going to be 90 minus y. Kind of refresh because my other proofs didn't come up. Okay. Next, we have to write this T-chart proof for the situation. So we have two givens here. We are given that BD is perpendicular to BA. And angle 2 and angle 3 are complementary. Okay, so let's go back up. What does it mean that angle, or that BD and BA, so that's these two right here, what does that mean for them to be perpendicular? Well, that means that this is a right angle. So I'm going to say angle ABD is a right angle, because that is what the definition of perpendicular means. So that means that angle ABD equals 90, because that is the definition of right angle. Okay, now it's telling me that angle 2 and angle 3 are complementary. Well, actually, I'm going to keep working with this ABD. So now I know that angle 2 plus angle 1 equals 90. Actually, I need to back up. Angle 2 plus angle 1 equals angle ABD, because that is angle addition. Now I can say, cross out the middle guys, angle 2 plus angle 1 equals 90 by, I got off on my numbering, transitive. Okay. Now I go back to my other given. Angle 2 and angle 3 are complementary, so that means that they add up to 90. Because that is the definition of complementary. So since angle 2 and angle 1 are both equal to 90, and so is 2 and 3, I can say angle 2 plus angle 1 equals angle 2 plus angle 3 by transitive. Subtract the angle 2's to both sides, and I get angle 1 equals angle 3 because of subtraction. Okay, the next one. OC is perpendicular to AB. It's the only thing we're given. So that means that OC and AB make a right angle. So we're going to say COB is right angle. That is the definition of perpendicular. Now, what does it mean to be a right angle? Well, that means that COB must equal 90 degrees. Definition of right angle. All right, so now that we know that COB equals 90 degrees, then we can write something about angle 3 and angle 2. So measure of angle 2 plus measure of angle 3 equals 90. Actually, we should say equals COB first. Angle COB. Because of angle addition. Then we can say, since the COB's cross out, now we can say measure of angle 2 plus measure of angle 3 equals 90 by transitive. And because things are equal to 90, that must mean they are complementary. That is the definition of complementary. All right, on the next one, we're given that angle, or that OA is perpendicular to BC, and that angle 2 equals measure of angle 3. So once again, what does it mean to be perpendicular? That means they make a right angle. So that means that, which one are we going to want to do? Angle AOC and angle AOB are right angles. Because of definition of perpendicular. So that means that angle 1 plus angle 2 equals angle AOC, and angle 3 plus angle 4 equals AOB. Angle addition. Then angle AOC and angle AOB equal 90. Definition of right angle. Then angle 1 plus angle 2 equals 90. And angle 3 and angle 4 equal 90, transitive. So angle 1 plus angle 2 equals angle 3 plus angle 4, also transitive. And we know that from step 2, angle 2 and angle 3 are equal. So I could replace angle 3 with angle 2 because of substitution. Then I could subtract away the angle 2's because of subtraction. Angle 1 equals angle 4, which is what I was trying to prove.